Hello, welcome back to the second part of the lecture. So in this part, we are going to focus on the exercise to show you the power of some of the command line tools. So I hope this setup is clear and you can see both my screen and my keyboard because we're going to work on the command line. So let's go to, this is on Mac, and we are going to use the terminal app. Okay, so that is the same with Linux. If you're on Windows 11 or 10, there's a new terminal app that you can use as well. So anyway, I'm going to maximize the font size of the screen. So hopefully it's clear to see. I think, okay, give me a second to make sure the screen capture is good. Okay, so I also hope the text is good to see. And without further ado, let's get to the exercise. So as I said in the first part of the lecture, we are going to do an exercise on the Shakespeare's collection. And so we're going to work on the 37 plays of Shakespeare and try to dig out some insights from the data set. It's a small data set, but it's good to explore the data set with our command line tools. So the first thing I would like to do is to, once you are in the terminal or in the shell, first thing you do is pwd to show where your current directory is. And normally I would like to go to my because you can see on the top corner of my desktop there is a shake directory or folder. So I'm going to go to from my home directory on Mac is username followed by users followed by my username, and then cd desktop will go to my desktop. And from there you can pwd again to show the current directory. Now I want to go to the shake folder. Okay, so in the shake folder currently there's nothing. Okay, but I'm going to use a command called wget, okay, to collect the data, to gather the data and download the data from a public source. So I'm going to copy over, and I'll make sure also to link to this data set in the description. But anyway, wget space URL to this data set and hit enter. It should be able to gather the data, okay, and save it as a local copy. Okay, so we can double check ls-l. You see there's a data set, Shakespeare underscore data.csv. Okay, so with that data set, first thing of course is to take a look at the data. So if we use cat and then it's capital S, so on command line it's normally case sensitive, so capital S. And then you see I did not type the entire file name. I simply type capital S and then tab. Okay, it will complete the whole file name for me. So this is a very useful shortcut. And then if I hit enter, I'm going to see lots of data. Maybe I can show you too much data to see. So what I'm going to do is to cat and then pipe to head. And then with head, I should be able to only show, for example, top 10 lines of the data set. So to go to the previous command, what you can do is press this up arrow key, going up, okay, to the previous one, and then we can continue to type something like head-10. Hit enter. It shows you the top 10 lines of the CSV file, including the headings. Okay, and so from the heading we can tell there's a data line, line number, exit line, player, and then player line, right? And the data follow. So the first task in this data set that we would like to do is to be able to do some basic counts, right? So let's do some counts of like how many lines are in there in this entire collection. So we can again shake, right? And then cat Shakespeare.csv pipe, and then remember this, the output will go to another command with pipe. Let's use wc-l to count the number of lines. And so this shows you it's like 111,000 lines or so in this entire collection. Now, in addition to that, let's also count the number of plays. Okay, so how do we count the number of plays? And so we remember that the second column is the play column, right? The second column is play. And so let's try to dig that out. So again, you can use this up, right, to go back, okay, and down to go back, go forward, okay. So what I can do is go back to the previous command and try to revise it from here. Okay, so because we are right now only interested in the second column, which is play, let's use awk, awk, and then the delimiter, as you can tell, is CSV, so comma is the delimiter. Okay, so -f, comma, space, and then here we need to create a very simple script with quotes. Okay, so I'm using 2 single quotes here, and then put a set of curly brackets. And inside the curly bracket, I'm going to simply say print $2. Okay, and so what that will do is going to single out the second column based on this comma as a delimiter. Okay, so again, I can print the whole thing out, but instead of doing that, let's continue to use head. Okay, so pipe it to head -5 to output the top 5. And let's take a look. Okay, so it looks like it works. It outputs, of course, play, and then Henry IV, because I think the first perhaps tens of thousands of lines are all about Henry Ford, right? So so that is to output the second column, which is play, but our purpose is not to just show the play, but to count them, right? How many plays are in there? And so what we do is we are going to use sort to sort all the plays. Okay, and again, I'm going to show you the perhaps all the data, but because it's difficult to see all the data and it will take many pages, there's another command I would like to briefly introduce, which is less. So pipe to less, okay, enter. So with less, it will allow you to page up and page down. So simply use space to go page down. But because all the play names are the same, so you don't actually get to see what are there, and then use Q to quit. Okay, so if you want to get out of it, just press Q to quit. But let's take a look at up to this sort. What is at the head? Maybe top 5. Okay, so a comedy of errors. Right, now we can also take a look at what is at the tail. So supposedly there should be something different. So that will tell us perhaps it's well sorted. Okay, so if it's sorted, that's good. After it's sorted, we want to run pipe this to, so again, go back to the previous command, and we know sorting is working. Okay, so all the play names will be sorted in an alphabetical order. And now we can run the unique. So pipe that sorted list to unique. Okay, and from unique we can also run the parameter of -c, okay, which is going to kind of remove all the duplicates, but also in the process of removing duplicates, count how many duplicates you have, which is basically the number of lines for each play. And so let's see what we get. Okay, so if you can tell, right? So after this unique, you actually see a number preceding each play name, and that is a number of lines for each play. Now, maybe you say, okay, I want to see which play has the most number of lines. We can continue to do piping. Okay, so from unique we have this list. Now if you want to sort this list by number, we can use sort dash n, which will sort by number. If and that maybe that's good enough. Okay, so sort them, and so it's in the descending order. Okay, and so the last one, Hamlet, turns out to be the one with the most lines. Okay, and so we get a distribution of the number of lines per play. Okay, so that is the first try on the command lines to run some basic statistic. And if you want to kind of sort the list in the reverse order, in the decreasing order, in the descending order of the numbers, you can do NR. Okay, but I will do this in another command. Okay, so let's go to the second task, which is to identify unique players and count them in each play. Okay, looks like this is a little bit trickier. So remember there are play and player columns in the data. Okay, play is the book, and then player is the character, right? And so I think essentially we need to identify, right, these two columns out, and then sort and aggregate them. Okay, and then after we sort them by play, then we can aggregate the players too, right? Remove the duplicates of the players, and so that we, for each play, we'll be able to have a list of unique players, and then we'll be able to find out how many players are in there for each play. So let's go for it. So again, we are going to cat Shakespeare, okay, and then with awk awk, right, again, two single quotes, and then two curly brackets, and then print. We are interested only in, I believe, the $2 and then $5. Okay, and we can double check because these, I believe, are the columns for play and player, which are what we are interested in. Okay, and so with this, we can continue. So go back to the command, and now we need to sort them. But before we do, there's also one more thing we do. When we print those, you see $2, $5, the two columns, it automatically put a space in between, which may be fine, but I would rather prefer to put a comma. Okay, so we'll continue this comma delimited, right, format. So what you can do here is that inside this expression, okay, move cursor to the comma between $2 and $5, and then put double quotes, okay, around it. Okay, that will essentially put a comma in between these two columns. Okay, so again, let's try it. 5, right? So you see player, and then for some of the lines, there's actually no player, so that's why it's empty. Okay, but for this one is King Henry IV, right? So with that, we can proceed. And now what do? We want to sort them, right? Want to sort because play is the first, so sort play first, and then player, and then next. So we sort them, and then again, if we, I always type 5st. Okay, so they are sorted, and also see, it's one play, the same play, and then the same name, and then if we use tail to take a look at the end, it should be another play, also sorted, right? So the same play and the same players will be sorted and will appear together. And now we know we can run this unique, right? We can run a unique to bring all the same play and player together. Okay, and so let's see what we get. Okay, so if we run unique, oh, that will, you see the players still stay together, but the players will be merged because the if you have the same player and the same players, you know, they will be considered duplicate and those will be removed. So we merge the duplicate players in the same play together, right? And so now what do? We want to count the number of, so basically once the duplicates are removed, these are the unique players in each play. Now we can count the number of lines in here for each play, right? In order to figure out how many um, players are in each play. And so right now we need to only single out the first column. So after the unique, we continue to run awk, okay, and then print $1. Okay, so why do we remember we used $2 and $5 from the previous CSV file, but right now because the output from the previous command, there are only 2 columns here, and the first column is actually the play, so we only need the play. That's why it's no longer number 2 column is now the number 1, the first column. That's why we use column 1. Okay, and so again, if we output, this will become, you know, just the first column. And if we simply just unique again, let's sort them again first. Okay, so again, I believe they are sorted, but it doesn't hurt to sort it again, and then we are going to run unique -c. Okay, and so if we do that, that will give us a number for each unique play, and the number indicates the number of players, unique players in that play. Okay, and so again, if you want to sort them, right, we want to figure out like how many, what is the play with the largest number of players in it, right? We can use n dash sort dash n, and then nr in the descending order. Okay, so now nr will give you the whole list, and you can go back, right? The top is Richard's third, which has 71 players or characters, looks like, right? And then in that order. Now, of course, if you say, okay, let's only look at the top 5, okay? And then again, it's very simple. With head 5, you'll be able to see the top 5: Richard III, Henry VI, Part 2, right, and so on. So this is to count the number of players, okay, which takes more steps. But again, you notice that the power of command line really comes from this piping mechanism. You can pipe the output of one command to another. Okay, so it's a whole workflow. And so I think the best way to think about command line and for this data analysis is to be creative in terms of the flow of data, right? So that you can best use each tool's power in this process. Now let's go to the third task, which is to search, right? So for example, I want to search, okay, again cat, and then you know the search command is grab, right? So I want to search for Brutus, right? So it's grab Brutus, and obviously I can take a look, right? And so these are all the lines, okay, containing Brutus. Now, if I want to just simply count the number of lines, right, containing Brutus, I can use the WC -L 152, right? Now, what is next? We are really interested here, not the lines, but what books or what plays contain Brutus, right? So we are not interested in all the detailed lines, but perhaps books. And so in this case, we still need to single out, right? Let's single out the second column. So print $2, right? So that's print $2. And again, take a look. So that is the play names, and they are duplicates, as you can see, containing Brutus. And so again, we need to merge the duplicates. So let's sort them and unique, right? So sort and then unique, hit enter. Okay, these are all the plays containing Brutus. So Antony and Cleopatra and so forth. These are the names of plays, unique plays containing Brutus. Okay, so this is the third task. The fourth one will be even more interesting. So let's say, okay, you really want to analyze Shakespeare's vocabulary, right? So you tend to run some term statistics, and one very common term statistic that people often rely on is term frequencies, the number of times. So you first need to identify the unique number of terms or words used in the text, and then also count the number of occurrences for each term. Okay, so that is term frequency. And with command line, it's actually very easy to do this task. Okay, so let's give it a try. So we're going to cat Shakespeare, right? And then I'm going to, because my focus is really on, let's head and then just review what we have, because in the end, we don't care about the play number X in player. We only care about the player line, because this is where our analysis will be focused on, right? So this line here, the actual text, right, is what we're interested in. So let's single that out. So org, right, -f, comma, and then we are going to print $6, right? So you can count 1, 2, 3, 4, 5, 6. Okay, so this is number 6. And again, take a look. Okay, so this is the line. Now, from the lines, what you also see is that I don't want the quotation marks, right? So let's see if we can remove those marks. And so here comes Pearl, right? In the last lecture, I talked about Pearl -PE that allows you to run Pearl inline, okay? And in PE, you can use regular expressions to do substitution. So I'm going to run a very simple substitution in single quotes, S for substitute, and then S, I'm going to replace quotes, okay? So double quote inside single quote is okay. If you're not sure, you can use slash, but that's not required here. Okay, so I'm going to search for quote, and then the replacement here is nothing. I'm going to just replace quotes with nothing. So immediately, I can put a space here if you want, but that's just immediately slash and then G, which is to run a global search. Okay, so replace every single instance of quotes. Okay, and so with this, we can output just a little bit. Okay, so you see the quotes have been removed, right? Okay, so we are good to go. Now, we can continue to pipe to another Perl. Okay, for now, we can do that. And the next thing I would like to do is to, again, we are going to split the words, right? We're going to tokenize the text using any punctuation as a delimiter, okay? So what I would like to do is to run this substitute, and in Python and in Perl there is this expression, okay, of punctuation. Okay, so this is for punctuation, And so whenever we see a punctuation plus, okay, because there can be one, at least one occurrence or more of punctuation. If they appear together, we are going to just convert them into a new line break, /n. /n is for a new line. So whenever you see a comma or a period, we'll break the line. And then /g, okay, for global search. So we can take a look. In order to see it more clearly, I would suggest you pipe to less, okay? So less, you enter, and you can tell, right? So now they are split into the individual words, okay? So for the punctuation, and so right now, when we run this, I think there is another better way. Let me try it, okay? And then, so what I'm going to do is add a /s, and then again run this. Let's see. Yeah, I think this works better. Okay, so punctuation /s for space, because we also want to consider, space. So we'll split those words and into lines, right? So each word will occupy a line, which gives us a great power to do things. Now, there's one more thing I would like to do. Remember, if you take a look at this, we can use head 2, pet 5. Okay, all these are either capital or lowercase, okay, in their original form. But perhaps you are interested in, like, let's say, maybe I want to kind of change everything into lowercase, right? So in Perl, you can also do that. I talked about the other two are called TR, which allows you to convert or do translation. But Perl also comes with that functionality. Okay, I would just do it, and then so this will actually change everything into lowercase. And so let's give it a try. Right, you see everything is lowercase. Perhaps you don't care whether they are capital or lowercase, and you want to perform this so-called case folding, okay, on the text. And so right now you have everything converted into the lowercase and one word for each line. Now we can sort them, right? We can sort, and again take a look. So if we sort, it does take a while to sort because we are sorting the entire collection of words. So, but anyway, so after we sort, let's run unique and then see, okay, that will allow you to kind of combine all the words and merge the duplicates together and count the number of occurrences. So this will actually give us a result. So if I run this, and I can actually redirect to a file, something like tfs.txt, okay? So I can redirect the result to tfs.txt for the term statistics. So let's do that, because this will probably take a while. Actually, it's quite quick. Okay, so take a look, and we can cat tfs and then head top 10. Okay, so you'll give us a list, and because the list, it has some numbers in there as well. So so the top is actually just numbers. Let me go to the tail, and so you will see at the tail there are words and then the number of occurrences of each word. Now it may be useful, and I think it would be very useful if we can sort, right, the numbers in the descending order. So we are going to sort the term by their frequencies, okay, and then pipe that to another file called tfs_sorted, okay. And now if we take a look at the tfs sorted, okay, and let's say want to take a look at the top 10, which is the top most frequent words. Take a guess. Maybe you will know some of those terms. I believe it should be unexpected, right? So the appears 20,000 times in the entire Shakespeare collection, and 15,000 times to 14,000 I, 14,000 of a, you, that. Okay, so if you look at the tail, I think you will probably see some rare terms in there. So actually there are numbers. Let us go to the top, maybe tail 100. Okay, and then I can tail 100 and then head 10, kind of, you know, somewhere in the middle. Okay, so it looks like these are not as common, right? Only appears once in the entire data set. Okay, so this is the way to run term statistics from the command line. And so this tutorial, this demo is simply to give you some idea about, how you may be able to use command line to do things. Unfortunately, I think part of my commands may be covered, but hopefully when I run it, you actually get to see my command. So that should also reveal itself after the command is run. But anyway, this is just an introductory and demo to show you the power of command line, and particular how you can combine these tools with piping to be able to do some basic analysis. And so it's something that you can quickly do without having to resort to kind of more powerful tools in even programming languages such as Python. Okay, so I hope this gives you some ideas, and we'll see you in future videos. Bye for now.